Okay, so today we're going to talk about writing and graphing parametric equations. So to give you a little bit of context, let's suppose that a baseball is hit with an initial velocity of 90 feet per second at an initial height of 6 feet and at an initial angle of 40 degrees. So then the ball's horizontal distance is given by the equation x equals 90 times the cosine of 40 degrees times t, which is how long after the ball has been hit, the t is, and its vertical distance is given by this equation. And again, t is the time in seconds after the ball has been hit. So we want to graph the path of the ball. And we want to think about what happens when t equals 0. Maybe 1 second after the ball is hit, 2 seconds, 3 seconds, 4 seconds, and so on. And then we need to get our x value and our y value. To make this easier on ourselves, we'll use our calculator. We'll hit the mode button. And we want to make sure that we're set to degrees. And then in the next line, we'll highlight PAR for parametric. Then we'll hit the y equals button. And what we'll see is a little slash with an x1 t equals, and then below it is y1 t equals. And we'll write the two expressions into the calculator. So we would put 90 cosine of 40 degrees. Make sure you close that parenthesis t, which is above, or which is the same button as the x button. And then 6 plus 90 sine 40 degrees t minus 16 t squared. Then we can hit second graph, which is really the table, and read the values directly from the table. When we do that, when when t equals 0, x equals 0, y equals 6. And then we can fill in the other values, well, round to the nearest tenth. You should take this time to make sure that you could enter all of this into the calculator correctly. If you have any problems, let me know. All right, and then 275.8 and negative 18.6. Since we got a negative y value, we know that at some point between the 3rd second and the 4th second, the ball hit the ground. So then we can go ahead and graph the path of the ball. And once we plot the points, we can graph the curve. And really, we don't need to go past the x-axis because we know at that point the ball is sitting on the ground. And if we were to imagine it, we know that the ball would basically be moving in this direction. So essentially what we've done is graphed a function with an x value and a y value, but we've considered it as it passes through time. And that's basically how parametric equations work. So we're going to say that t is a number in some interval, and then the plane curve is the set of ordered pairs, x, y, where x is a function of t and y is a different function of t. The t is the parameter, and the equations x equals f of t and y equals g of t are parametric equations for the curve. We always need to consider the orientation, which is the direction along the curve as t increases. So as the ball went up and then as the ball went down. So in the two examples we're asked to graph them, we're given intervals. They happen to be the same interval from -2 to 2. So we'll go ahead and make a little txy chart. And for t, I'll pick -2, -1, 0, 1, and 2. And then I'll plug these values into the parametric equation x equals t squared minus 1 and y equals 2t. So x would then be 3, y is -4, then 0, -2, -1, 0, 0, 2, and 3, 4. What we're plotting are just these points here. We're going back to a rectangular coordinate system. So we'll plot 3, -4, 0, -2, -1, 0, 0, 2, and 3, 4. We don't go past our two endpoints because it's a specific interval. But what it looks like we have is part of a parabola facing sideways. And we know that we travel along the curve in this direction. So we need to make sure that we put these arrows in to mark the orientation. And there we've done it. We've graphed our first set of parametric equations. We'll do it again. Make another t x, y table. I'll pick the same values for t. And then plug them into these two parametric equations. When we do that, we get -1, -6, 0, -3, 1, 0, 2, 3, and 3, 6. And then again, we're just going to graph the xy values because we only know how to graph in an xy system right now, in a rectangular system. -1, 6, 0, -3, 1, 0, 2, 3, and 3, 6. What we have actually appears to be a line. But again, we need to remember to mark the orientation with arrows so that we know which direction this travels. Let me know if you have any questions.